Okay, so 8.1, we're only doing 2 sections in topic 8, but there's going to be a lot of stuff in it, and we're going to spend a lot of time. It's important that you guys practice every day, so if you need more practice, I can give it to you. Does it make sense what I'm saying? If you're not doing your homework, I'm not going to give you more time to not do your homework. Does that make sense? So if you're not doing your homework, we're going to move on. If you're doing your homework and you need more practice, then we'll do what? More practice. But if you don't need more practice, we move on and it gives us more time to spend on the stuff we have. We need more time. Got it? That's how that all works. Sorry for the heading being small. If you don't like it, highlight it. It's right there. So, topic 8, section 1, right triangles and Pythagorean theorem. Have we already used the Pythagorean theorem in here? Yeah. Yes, at least twice. Right? So, what is it? A squared plus B squared equals C squared. It can only be used on what kind of triangles? Right triangles. It cannot be used on anything that is not a right triangle. We can write this. This gives me, oh wait, what are A and B? What are they? Legs. And what is C? Hypotenuse. And I'm just going to abbreviate. Okay, legs are legs. And hypotenuse is a hypotenuse, but how do you tell the difference?
Hypotenuse is the longest side or the side the right angle is pointing to.
It's the longest side opposite the right angle, correct? And the legs, what? Don't they make the right angle?
Yeah.
Okay. Does it matter which leg is A or B?
No.
Does it matter what's the hypotenuse?
Yeah.
Yes. Okay, so if I wanted to solve this just for C, because I have C squared, how do you undo a square? Square root. So I would have C equals, and when I take a square root, it's always plus or minus. Whoever's jiggling, can you please stop? The square root of A squared plus B squared. Now, it's always plus or minus, but we're talking about sides of a triangle. Can you ever have a negative length? No. So it's always going to be the what? The plus. But I want to keep pointing that out to you. When we take the square root, it's plus and minus. But sometimes they're not always good answers. We have to know when it's both answers and when it's only one of them. Okay? So that gives me the hypotenuse. But what if I want a leg? So if I want A, how do I solve this equation for A? I have A squared plus B squared equals C squared. How would I move B? Subtract it from both sides. And take what of it again? The square root. So A would equal plus or minus, which one? Plus. The square root of what?
C squared minus B.
C squared minus B squared.
So when you're looking for like A or C, you just take the square away from it?
Yeah, after you move.
Okay.
Yeah. Okay, does C have to be first? Think about it. C is the hypotenuse. It's the longest side of the triangle. Does it have to be first? Yeah. Because if it's not, you're going to have a negative number. Can you take the square root of a negative number? No. And the math doesn't support it, does it? You have C squared by itself. You subtract over B squared, don't you? So what if I wanted B? You would subtract over A. So it'd be plus or minus, which one? Plus C squared, the square root of C squared minus A squared. Either one would be used to find a what?
Leg.
A leg. Again, doesn't matter which one's A and B. No. So do you have to remember both of these? No. You don't even have to remember one of them. All you have to remember is A squared plus B squared equals C squared and move it around, right? But let's look at some things. When I'm looking for the hypotenuse, I do what to the two sides? Add them. And I take the square root. Or I square them, then take the square root, right? When I'm looking for a leg, what do? Subtract the leg from the what? Hypotenuse. You square them and subtract them. Is that going to happen every time? Yes, every single time. So if you remember that, will it make your life easier? Yes. So we've said if it's a right triangle, then a squared plus b squared equals c squared. So if a squared plus b squared equals c squared first, then we know it is a what triangle? A right triangle. So if we know it's a right triangle, we can use the Pythagorean theorem to find a missing part. But if we don't know if it's a right triangle, can we use the Pythagorean theorem to check if it is? Yeah. We said C is always the hypotenuse, and we said two characteristics. It's across from the right angle, but if you don't know which one's the right angle, how do you know which one would be C? It's the longest side. So do you need to know both of those characteristics?
Yeah.
Yes. Okay, so find the measure of the missing side. So what am I looking for? A leg or a hypotenuse? A hypotenuse. So I'm looking for C. So C equals the square root of what?
12 squared plus 15 squared.
12 squared plus 15 squared. Because when I'm looking for the hypotenuse, I'm adding the legs, right? And this is why we should know our squares and cubes, because it will make our life much easier. 12 squared is?
144.
And 15 squared is?
225.
225. And then you add them. Can you add them before you square them?
No.
The answer is no, because order of operations says exponents, yes? And then addition later on, after a couple of other things. Okay, let's see if we add them the same. You add them, I add them, and we better get the same answer, right? I got 369.
Yeah.
Got that? Okay. And yes, you have to simplify them. So we're looking for perfect squares. So 4, 9, 25, 16, 36, 49. You're shaking the whole room. If you guys are shaking, watch that. The whole thing will start shaking. Because you're moving too. Okay, so I'm not going to look for 49 or 81 or 64, are you? No. But I am going to look for 4 and 9. Those are going to be easy to look for. So I'm going to go over the rules again. If it is divisible by 4, first of all, it has to be an even number. Correct? Is this an even number?
No.
No. If it was, you cover up all the digits. I don't care if there's 18,000 digits. You look at the last two, and if 4 goes into the last two digits, it goes into the whole thing. That is the divisibility rule for 4, and it works every time. 3, you add them all up, and it's divisible by 3, right? But I don't care about 3. I care about 9. But guess what? If you add them all up and the number you get is divisible by 9, it's divisible by 9. So what is 3 plus 6 plus 9?
18.
18. So does 9 go in the whole thing?
Yes.
Yes. So we have the square root of 9 times 36 is 4 and 9 is 1. Okay, 41. Well, 4 plus 1 is 5. 4 doesn't go into it. It's odd. 9 doesn't go into it. Is there going to be any other perfect square that goes into 41? No. So what is the square root of 9? 3. So 3 square root of 41.
Is the answer?
Yep.
Oh.
I don't ever want a decimal answer, because to get the answer to this, you would have to use a calculator. Now, if we do If we do IXLs, sometimes they say round to the nearest tenth or whatever, then will you need a calculator? Yes. You just put that in your calculator. Okay. Am I finding a leg or a hypotenuse?
A leg.
A leg. I'm going to name it, well, actually, it's across from D, so the name is actually what? D. If it's across from angle D, it's side D, and it's a lowercase. But does it really matter what I call it?
No.
It's a what? Leg. So if it's a leg, it is equal to the square root of the hypotenuse. What's the hypotenuse? 10 squared minus 7 squared. So 10 squared is
100.
minus,
49.
and I'm pretty sure we have the square root of 51. Yes?
Yeah.
Okay. Well, 4 does not go into 51 because, first of all, it's not even, right?
3 does.
What?
3 does.
3 does, but is that going to help me? Maybe, maybe not. But I was going to check 9.
Oh, yeah.
5 plus 1 is 6, so 9 doesn't, right? But 3 does. So it'd be 3 times. Well, 3 goes into 5 how many times?
1.
1. With 2 left over, so that's 21. 17. So I got 3 and 17.
Doesn't help.
Nope. So my answer is just the square root of 51. Now, I have a question for you. Square root of 51 is a decimal, right? Some number. What two numbers is the square root of 51 between? What two whole numbers is the square root of 51 between? What are the perfect squares that are smaller than 51 and bigger than 51?
7 and 8.
Well, 49 and 64, which would be 8 and,
8.
how about 7 and 8? Not 8 and 8, because I was going to do it. 7 and 7, yes?
7 and 8.
I just want to have a double. Okay, 7 and 8, yes?
Yes.
Okay, so it's somewhere on the continuum between 49 and 64. Is it closer to 49 or closer to 64?
49.
It's really close to 49, isn't it? So if the square root of 49 is 7, the square root of 64 is 8, what do you think the square root of 51 is?
7.3.
Anybody else? 7 point what? 3.2. It's actually 7.14. Yep, 7.14. I would have never guessed anything other than 7.1 because between 49 and 51 there are 2 spaces, yes? Between 51 and 64 is 13.
Oh.
So now when I say it like that, where are you going to go? You're going to go 7.1, aren't you? I'm not going to ask you to do that, but in your brain, should you be able to think about a number and get fairly close? Yeah. If you would have said 7.2, I probably would have been okay with it. 7.3, I probably wouldn't have just because it's only 2 away and 13 away.
Yeah.
But what if I ask you about the square root of 60? Where's that going to fall?
Like 7.8.
It's going to be like 7.8. So, I don't know. Let's see. $7.745. So do you see how you kind of can estimate that? I'm not always going to ask you that, but if you ever had to put it on a number line, should you know pretty close where to put it? Okay. So the next one, is a triangle a right triangle? Well, if it's a triangle, what's true? A squared plus B squared equals C squared. So C is across from the right angle, but we don't know there's no right angle, right? So it's also what? The longest side. So what's my C?
37.
37. So 37 squared. Does it matter A and B? Nope. So 35 squared plus 12 squared. Now that's a lot of math, so I'm going to make Jenna's side do 35 squared. You guys do 37 squared, and I get to do 12 squared. I'm done.
Yeah,
Aren't you done yet?
It is so hard, Miss Meg.
Okay,
So hard.
go for it. Do your number. Jenna's side's 35 squared. This side's 37 squared.
More than that.
Thank you.
But I don't know if that's right.
But my answer probably.
Hey, cheater. I'm kidding.
And I'm doing both, so you guys can't complain.
Oh, good night. Yeah.
Did you get the same numbers I did?
Yeah. You did actually.
Well, you should have beat me. I had to do 2 of them. I had to do 3.
I beat you.
Good. Okay, so I get 1,369 on the right. And the left, I get 9, 6, 2. Oh, this is wrong. You guys should have caught me. This is 225. It could be. It could be like not true, right? But I knew it was. I didn't carry my 1, did I? So I have 9, 6, 3, 1. So is this a right triangle?
Yes.
Yes. So it's a right triangle. Okay, so where's the right angle at then?
Opposite of 37.
So opposite of 37 is M.
Angle M.
So you can put that there. Now, when it asks you if it is a right triangle, you have to do all these steps. You have to go through it and show me the left is equal to the right. Okay? You're proving it. If it's not equal, you cross out the equal sign, says not equal, right? And you say not a right triangle. It's not hard, is it? Oh. Next. Okay, we're going to go through these together.
Are you doing all this today?
No, just this page. Okay. So, leave your answer in simplest radical form. You start giving me decimals. I know it's just a no. Okay? Leg or hypotenuse?
Hypotenuse.
Okay. So, am I going to add or subtract them?
Add.
Add. So, x equals the square root of 6 squared plus 9 squared. So, the square root of 36 plus 81. So the square root of 117. Okay. Now what?
You find it.
You have to simplify it, right? So the ones I'm always going to check are 4 and 9. Why am I going to check 4 and 9 first? They're perfect square, and do I have 2 easy rules that tells me? Okay. If not, then I have to go to 3 and go on from there, right? Okay. Is 4?
No,
Why?
it's not even.
It's not even. Don't even have to look any further. It's not even, right? 9.
Yes.
Why?
Because 9 can go into all of them when you add them.
Because 1 plus 1 plus 7 is
9.
9. So 9 goes into it. I know it does. So 9. 9 goes into 11 how many times? Once. With what left over?
2.
2. So we put a little 2 there, right?
3.
And 9 goes into 27. 3. Well, 13's prime, right? So what's the square root of 9?
3.
3. And square root of 13. Because there's still a square root over here, isn't there?
Yeah.
Okay. The reason why we're doing so many is because there's different sides and the way sides can look, and I wanted to go over all the rules with you again to make sure we had them. So I have x, square root of 10, and 5. Am I looking for a leg or hypotenuse? Leg. So am I going to add or subtract?
Subtract.
Subtract. Okay, the square root of hypotenuse first. What's the hypotenuse? 5. Now, I have a question for you. So it's 5 squared. I've had people argue with me that the square root of 10 is bigger than 5. Is it? No. Because 5 is the square root of 25, right? There is no way 10 is bigger than 5, is it? Okay, so now add or subtract? Subtract the square root of 10 squared. Well, square root, 5 squared is 25. Minus, now, when you square a square root, those are the opposite operations, yes? They undo each other. The answer is just 10. Now, I'm going to show you why before we keep going, so I want everyone to watch me why. Okay, you don't know it yet. You may have, you may not have, but a square root is actually the exponent of 1/2. Okay? That's what it is. Kind of makes sense, right? Square root, you were looking for pairs of 2. Guess what the cube root is? 1/3. Fourth root, 1/4. Okay, now you're going to square it. Well, when I take a power to a power, don't I multiply them?
Yeah.
Well, what's half of 2? 1. So the answer would be what? 10. Another way to look at it. Square root of 10 squared. Well, what's 10 squared? What the square root? Yeah, 10 squared is 100, yes? What's the square root of 100? 10. So either way, the answer is what? 10. So do we like to see the square root squared?
Yes.
Do we like to see the cube root cubed? Yes. Okay. So 25 minus 10 is 15. Do we even have to think about this one? No, because it's 3 and 5 and we're done. 3. Leg or hypotenuse? Leg. That is the first thing you ask yourself, yes? So it's a leg. So am I going to add or subtract? Subtract. So you fill it in. You got it filled in yet?
Yeah.
Okay. Don't go any further. Now, does mine look different than yours?
Yeah.
What looks different?
The
The parentheses. I'm right, you're wrong.
Well,
Okay.
be right, Miss Meg.
Now watch. You guys all have this, yes?
Yeah.
Yep. What's the square on?
Outside of the parentheses.
Well, no, on yours. What's the square on?
Oh, on
The 3, right? So the square root of 3 squared is what?
the 9.
3.
3.
So it'd be 2 times 3, which would be what? 6. Okay, now, what is my square on? All of it. So it goes to where?
The 2 also.
The both. So 2 squared is what? 4. And the square root of 3 squared is 3 minus, and what's the square root of 5 squared? 5. Still all in the what? Square root. So 4 times 3 is what? 12. Is 6 the same as 12? No. So, do parentheses matter?
Yes.
Yes. Make sure you're putting your parentheses. That's why I wanted you to stop at filling it in. Okay, 12 minus 5 is 7. So the square root of 7. Do I need to go anywhere?
No.
Please no, because it is prime, yes? Okay. Leg or hypotenuse? Hypotenuse. Add or subtract? Add. So now I'm going to let you go all the way. If you get done with that before I start talking, go to the next one. Only if you're using a pencil. Can I start?
Yeah, you're good.
So I'll have the square root of 20. Okay, what do I do from there?
Wait, how did you get 20?
14 plus 6.
Oh. And then 4 times 5.
4 times 5. The square root of 4 is
2.
2. Now I'm going to tell you, before we're done with this topic, you all should be able to see square root of 20 and say 2 square root of 5. Square root of 12, 2 square root of 3. Square root of 8, 2 square root of 2. You are going to see, and square root of 24 is the other one. 2 square root of 6. You are going to see the square root of 24, the square root of 20, the square root of 12, and the square root of 8 over and over and over again.
Can we finish off?
Yeah, we will. Okay? But you get what I'm saying? You'll start seeing those numbers again. You guys already working on 5?
Yeah.
Okay. Work on 5 and 6. Make sure we're doing them right. If you need help, stop me, okay? Okay, did you get 2 square root of 6?
Yep.
2 square root of 5?
Yes.
Is there a lot of ways I can get the square root of 20? Yeah, there's a lot of ways. Any questions on those, guys?
No.
Okay, please, some mistakes people make. They put the square root in the first one and they don't carry it down, and when I say something like, I know it's there, what happens? They forget. Leave it there till you do it. Okay? Now the bottom 4 says, finding the missing sides of each right triangle. So since they told me they were right triangles, what can I use? Pythagorean theorem. Side C is the hypotenuse. So that means A and B are what? Legs. You can draw a picture or you don't have to draw a picture. Okay? All I want you to do is set these up so we don't run out of time. I want to make sure they're set up right, okay? So you set them up. You want to do one together?
Yeah.
Yeah? Okay, I have A and B, so I'm looking for what? C. So add or subtract? Add. See how I'm asking myself the same questions every time? So 9 squared plus 7 squared. And we'll work them in a minute. Go to 8.
Okay.
Okay, I got A and C. What am I looking for? B. A leg. Add or subtract? Subtract. So then it's what? 13 squared minus the square root of 122 squared.
I put them backwards.
No, you can't. Doesn't matter on this one.
What?
It matters. Like C has to go first. Okay? Now you guys set up the next 2. And then if you get done setting them up, you can go back and work them. I want to know who panicked when they saw 257 and thought they had to square it for a minute.
I just almost had an aneurysm.
And then you're like, wait a second, I don't have to square that, do I?
Do we have a worksheet?
Yep, you do.